7 is slightly different from your previous weeks. So
Yes, sir. The sequence thing and all are really very difficult kind of thing.
okay.
Sir, in limits, there is some theories.
Okay, so yeah, so yes, certainly it will be slightly difficult for you.
And
Then
the tangent of floor and ceiling function, this is also.
no, yeah, so tangent actually is now, so maybe in the later in the maybe next week you will see that tangent thing more precisely, like how we are doing tangent. So but in this week like SAR has done it vaguely. Okay, so he gave some vague idea about tangent. Okay, so he'll define it like so to talk about tangent, so you need differentiability. Okay, so he'll define like how you can construct tangent, but okay, so vaguely you should not have any kind of jump or any kind of corner point on the graph. Okay, then actually you can talk about the tangent. Okay, so let's discuss few things like I'll discuss few things from
Sir, can I ask one thing?
Yes, please.
How that floor and ceiling function will come in the exam exam? What the maps of that? The concept floor and ceiling got it, but what the application of this thing? How the maths are going with this concept?
No, in the sense like what do you mean by application? In what sense you are
Mathematics in exam.
oh, in exam. See,
Yes.
exam. So, see, in exam mostly like in exam mostly we'll see question like relate mostly on whether some function. It doesn't matter whether it's a greatest integer function or
Least
small,
integer.
yes, least integer or smallest integer function. So it's mostly it will come like whether this function is continuous or it's whether it has some left hand limit or it has some right hand limit. So mostly question will come similar to this. Okay, so but yeah, so it's depend like so yeah, so it's not that only some greatest integer or smallest integer function will come, but yeah, different kind of function, we may ask different kind of function and we can ask about to check the continuity or maybe differentiability or limit. Okay, so yeah, so okay, let's start. Okay, so you know sequence, right? So can one of you tell me what is sequence?
Where an is more getting closing to a, like for increasing n.
No, I'm asking about the definition of sequence.
All the values taken by n or a.
Sequence is a special kind of function where sequence is a special kind of function where n is integer and a is not equal to 0.
No, that is not correct. So the precise definition of sequence, it's basically it's a map. It's a function from the setup. So in this course, actually, we are only dealing with real sequence. So basically, we're dealing with real sequence. Okay, so all the terms in a sequence, they are always real numbers. Okay, so we are not going to deal with complex sequence. So in this course, we're always going to deal with real sequence. Okay, so sequence is a map. So it's a map from the set of natural number. Okay, from the set of natural number.
Yes, natural numbers.
To
real numbers.
Yeah. Okay. So again, I just want to let you know that in this calculus part, so 0 is not in 0 is not a member of n. Okay, for the calculus part, we are not considering 0 as an element of the set of natural number. Okay, so natural number starts with 1. Okay, so natural number is, so for calculus part, start with basically 1, 2, 3, and so on. So it's basically it's a map from the set of natural number to R. So in general, you don't see sequence in this form, right? So in generally, when you see question, you don't see you don't see sequence as a function. What you see, you generally see is as a list of elements. Okay, so some kind of list of elements. For example, say this is my sequence. So the first term of the sequence is 1. Okay, A2 is, let's say, 2 square, A3 is 3 square, and so on, and the nth term of the sequence is nothing but it's n square, right? So this is my sequence. So in general, you see sequence in this form, right? But the thing is, I can associate this list of element to a function from n to R. So how I will associate? So as you can see, so here I'm denoting each term of the sequence with some index 1, right? And the second term of the sequence, I'm denoting A with some index 2. And the third term of the sequence, I'm denoting this as A some index 3. And the nth term of the sequence, I'm denoting it as A some index n. So for 1, so here the index is 1, and what I'm getting, so here A1 is 1. So what I can do, I can define a map. So from this sequence, I can define a map from the set of natural number to R. So how I define? So the image of 1, so 1 goes to my A1. So what is A1 here? Here A1 is 1, right? And what is the image of 2? 2 goes to A2, which is 2 square, right? And so on. Like if the image of n is basically an, and n goes to n square, right? So this is, so so if I have a sequence, for example, if I have some list of elements, okay, so by this list of, so I can associate one function to this list of given elements. Okay, and similarly, if I have a function, okay, so similarly, if I have a function, right, if I have a function, let's say I have a function from natural number to R. So what is my function? Let's say my function is n goes to 2n plus 1. This is my function. So if I have a function like this, then I can create a sequence out of this function. I can create a sequence from this function. And what is the first element of this sequence? That is A1. What is A1? A1 is nothing but f of 1, right? So what is f of 1 here?
1 square 1.
No, for this function.
3.
It's 3.
2n plus 1, sorry, yes, 3.
Yeah. So similarly, so A2 is nothing but, so similarly A2 is basically f of 2,
5.
which is 5.
5.
And similarly, I can say my nth term of the sequence is nothing but f of n, which is 2n plus 1. Okay, so the moral of this story is basically, if I have a sequence, some sub list of elements, so using that sequence, I can construct a map from the set of natural number to R. Okay, and similarly, if I have a function from natural number to set of real, then I can construct a sequence from that function. Okay, so from here to I can go to here, and from here to I can come to here. Okay, so basically the sequence is nothing but it's a function from the set of natural number to R. Okay, so is it clear, or what do we mean by sequence?
Yes, sir.
Yes. Okay, so okay, so let's see some basic property of sequence and convergence of sequence. So suppose
Sir, in real number, basically we count minus part also. In this, can I count 0.1, 0.2, 0.3?
sure. For example, you take this sequence. For you take this sequence. Like for my first term of this sequence is 1. Okay, my second term of the sequence is 1/2. My third term of this sequence is 1/3, and so on. You can take anything. Like it's the one thing is it has to be a real number. Okay, it doesn't matter what real number you are taking. Okay, you can so you can take some maybe you can take some sequence where a1 is pi. Okay, a2 is e, a3 is pi square, a4 is e square, and then f5 is phi cube, and you can keep on doing. Okay, so it doesn't matter. So the main thing is this ai's a1 and a2 and a3, they should be a member of R. Okay, that is the condition we need to follow. Okay.
And output will be unique, or it will be repeat? Right.
No, it doesn't matter. Like it's a function. So I'm just saying that it's a function. Okay, I'm not putting any condition on the function. Okay, so it can be 1, 1, it can be on 2. It can no, certainly it cannot be on 2. It can be 1, 1, and it may not be 1, 1. That is fine. Okay.
And
So for example, you can take this sequence. This a1 is 1, right? A2 is -1, a3 is 1, a4 is -1, and so on. So this is basically a n is basically
minus 1 to the power n.
N plus 1. Okay, so this is the sequence. So it doesn't matter whether your sequence keeps repeating or is element of the sequence they are distinct. So it doesn't matter. So there is no condition on the sequence. Okay, so only condition is it has all the elements of that sequence has to be real. Okay, that is the only condition I'm putting on the sequence. So that's why, as you can see in the beginning, I'm considering a map from N to R. Okay, so real.
sir, in this function, we can only enter, as a domain, we can only enter natural number, right?
Correct. Yes.
Yeah, and we can get the minus also as a result.
Yes.
So,
Okay. So suppose so let's go and talk about some property of the sequence. Okay, someone raised hand. So Devan.
Yeah, sir. Sir, there is a question in graded assignment 7, question number 10. I am just concerned whether the sequence is correct in it or not, because it says 15 plus 25 plus 35, then in the end it's 10 and minus 5. If I put 1, I'll not get the first element of the sequence. Can you please check just once?
Sorry, question number?
Question number 10.
Yeah, I'll come to that. Okay, so yeah, I'll check. Like I'll come to that once you can.
Yeah, sure.
Yeah.
Okay,
So
thank you.
yeah. So suppose you have a sequence. So my sequence is basically A. Okay, so this is my sequence. So as you can see, so this is one of the way to represent a sequence. So this basically means I have this sequence A1, A2, A3, and so on. Okay, so when I can say that this sequence an has so sequence an has a limit a. So when I can say that the sequence an has a limit a. Okay.
When it goes closer to A.
Yes,
like,
yes. So I can say that the sequence has a limit a if 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 the numbers of the sequence comes closer and closer to a. Okay, once you increase the value of n. Okay, so for example, this sequence, so if you consider this sequence an, if you consider this sequence 1 by n, okay, so as you can see, the first term of the sequence is 1, the second term of the sequence is 1 by 2, the third term of the sequence is 1 by 3, and the fourth term of the sequence is 1 by 4. And as you can see, if I keep increasing the value of n, the sequence will come closer and closer to 0, right? So that's why I can say that 0 is a limit of this sequence a. Okay, so in general I can say that, okay, please mute yourself. So in general I can say that a sequence an have a limit a if the terms of the sequence comes closer and closer to a if I increase the value of n. Okay. Okay, so if the sequence an has a limit, then I can say that the sequence an is a convergent sequence. Okay. Okay. For example, if you consider this sequence, for example, if you consider this sequence an, so here an, which is 1 by n, so this has a limit, right? This converges to 0. That's why I can say that this sequence is a but if I consider this sequence an equal to n, okay, if I consider this sequence an equal to n, as you can see, if I take the first term, this is 1, second term 2, third term 3, fourth term 4, so the nth term is basically n. So if I increase the value of n, so if I increase the value of n, then as you can see, the an basically it's going towards infinity, right?
Sir, but yes, I have some doubts in this. Like, if it is increasing, but it is going closer to like infinity
No,
is not defined.
No, I'm not. Now I'm not talking about increasing or decreasing sequence. I'm just talking about the limit point of the sequence. Okay, so it's not going towards any particular point, right? This sequence, if you increase the value of n, this sequence is going towards, it's basically increasing. It's going towards infinity. Right? It's not going towards any particular point to some particular real number. It's going towards infinity, right?
Yes, sir.
Infinity is not a real number. Okay, it's not a real number.
Not a real number then?
It's not a real number.
I didn't know that.
So how we define it? Like,
how? So that's why this sequence don't have any limit. Okay, so this is a divergent sequence. If you increase the value of n, the sequence is not going. It's not, the terms of the sequence is not going towards any particular point. It's going towards infinity.
but in the lecture, sir said that it can be called as a convergent, something like that.
No. I guess so. That is a different thing. That actually you can, for that you have to extend your number system. Okay, so for that you have to extend your number system. Then you can, in some different number system, you can say that the sequence is convergent. But certainly you cannot say when you are doing all these things in R. Okay, so in this course we are dealing with only real. Okay. So that's why, as you can see, if you increase the value of n, these terms of this sequence, they are going towards infinity, right? So that means it's not a convergent sequence. Okay.
Okay.
So
Sir, one thing, this function is converges to 0. What does it mean by that? Converges to 0.
Which one?
The word. The 1 by n converges
to
to 0
zero.
means
That is what it is written. Like I can say that an is said to have limit a. Okay, that means an basically convergence to a. Okay.
See that word mean converges to a. What does it mean? Equal to a, tends to a.
That is tends to.
Okay.
So as you increase the value of n, the terms of the sequence will come closer and closer to 0. Okay, that is what it means. Okay. Okay. So this sequence an is
similar to this n, minus n will also be the divergent sequence.
Correct. Yes, because if you increase the value of n, it's not going towards any
go to
particular
negative infinity.
It's going towards negative infinity. Okay. So similarly, you can say that an minus n is also a divergent sequence. Okay, and with the same logic, you can say that an, which is minus 1 by n, this is convergence to 0. This is minus 1 by n.
So, sir, can we take minus value as a we can put the minus value like minus 1 or minus 2, minus 3?
Yes.
There is no restriction in that.
That is what I have. Someone already asked. Like as you can see here, I am taking minus 1, right?
Okay.
So the thing is, as I said, you can take any real number. Okay, if whatever you are taking, if it is a real number, then you are okay.
But sir, in the domain, it has mentioned that is
then you have to see like how I have constructed this from the domain, how I have constructed the sequence, right?
Okay.
I'm taking, so this A1 is basically it's in the co-domain of the function. It's not in the domain of the function, right?
Got it.
Yeah. Okay, so if a sequence has a limit, then we say that sequence is a convergent sequence. If that sequence don't have any limit, then we say it's a divergent sequence. Okay, so that is basically the terminology. If an is a sequence and it has some limit, then we say that sequence an is convergent. If the sequence don't have any limit, then we say that sequence is a divergent sequence.
So how to understand this sequence has a limit?
Yeah, so the thing is, you have to see carefully. Okay, so you have to do bunch of problem, then only you can easily realize like how the sequence behave. Okay. So yeah, so we'll discuss few things. Okay, so the next thing is next we are going to use few property of sequence. So suppose I have two sequence. Okay, so suppose I have a sequence an. So an is a sequence. Okay, and bn is another sequence. These are two sequence, and I am assuming that both the sequence are convergent sequence. Okay, so limit of an converges to a, and bn converges to b, right? So the sequence, both an and bn, they converges to a and b respectively. Okay, so since I have two sequence, I can take the sum. Okay, so what is the sum of two sequence? So this is my sequence an, and this converges to a, and I have another sequence bn, which converges to b. So I can construct another sequence. So what is that sequence? That is basically nothing but the sum of two sequence, right? This is the sum of two sequence. Now this is a new sequence, right? This is a new sequence I'm getting from these two old sequences, right? So what is the first term of this sequence? What is the first term of this sequence, new sequence?
A1 plus B1.
A1, B1.
B1, right? So this is a new sequence. The first term of this sequence is A1. the first term of this sequence is B1.
B1.
So when I'm adding these two sequence, I'm getting something new. Okay, so A1 plus B1. The second term is A2 plus B2.
B2.
And the third term is A3 plus B3. And so on. So what basically this first statement is saying, that it's saying that if An converges to A and Bn converges to B, then this new sequence will converges to this new sequence, which is basically the sum of the previous one. This will converges to A
plus B.
B. Okay,
this is only applicable for the convergent
correct
sequence only.
Correct. If An and Bn they are convergent, then only you can apply it. Okay, for example, yeah. So for example, you take this sequence. So suppose my sequence An is 1 by n, and my sequence Bn is 1 by n square. So this is my sequence An. So, and you can see this An converges to 0, right? And Bn also converges to 0. Yes. Suppose you want to know what is the limit of this sequence An plus Bn, which is nothing but basically what? This is n square n plus 1. Okay, so you want to know the sum of limit of this sequence. So this limit of this sequence is nothing but A. So this is here A is 0, and as well as B is 0. So this is nothing but the limit of this sequence is A plus B, which is 0. Okay, so this is what this first statement is saying. Okay, so if I have two sequence A and B, then the sum of the limit of the sum is basically sum of the limits. Okay. Is it clear, like how actually we are constructing the new sequence and how we can get the limit of the new sequence using the previous two limits?
Yes, sir.
Yeah. So for example, so since you asked, like we can only apply this thing for convergent sequence. Okay, so basically you cannot apply it for divergent sequence.
Sir, suppose An has a limit, like its limit to like
can you someone, I'm getting a lot of noises on the background.
Am I audible?
Yes.
Sir, suppose there is An is going towards like limit 2, and Bn is going towards closer to 3. So we will add.
No, sorry. Can you repeat? I'm having issue with the noise.
Am I audible, sir?
Yes, please. Yeah.
So actually, I was saying that let's suppose An is going closing to like 2, limit is 2, right? And
so suppose you have a sequence and the limit of the sequence is 2, correct?
Yes. And Bn is going towards 3, like more closer to 3.
Limit. So basically, you're saying the limit of Bn is 3, right?
Yes. So we can plus both. If we plus An plus Bn, so it will be 5. No, like it will going to.
Yes. That is what.
More closer to 5.
Not more closer. Yeah, it's better to use this An and Bn have limit 5. Okay, so that is more or less same as if you increase the value of n, then An and Bn will come closer to 5.
And sir, it will affect like An is going more slowly to closer to 2. And
it doesn't matter. It doesn't matter whether An is going slowly or going fast, or it doesn't matter. Okay, so it really doesn't matter. Okay, so so you should not care now. You should not care about how this An is going. Okay, so you should not care about the order in which the sequence is going towards 2 or going towards 0. Okay, now only thing you should care to which point this sequence is converging. Okay, what now the main aim for you to find out the limit of the sequence. Okay, you don't care about the order. Okay, so the next thing is saying, so this is basically saying, so suppose you have a sequence An, Suppose you have a sequence an and the limit of the sequence is a. Then what I can do, I can construct a new sequence by multiplying some constant, some real number c with all the terms of the sequence. Okay, so if I multiply c with all the terms of the sequence, I will get some new sequence. What is that sequence? This is basically CAN, and the term of the sequence are basically CA1, CA2, CA3, and so on. And if I know the limit of an, then quickly I can say what will be the limit of this sequence. So the limit of this sequence, is basically c times a, right?
Okay, now I got this thing.
So for example, if I have a sequence, let's say n square plus 1 by n square plus 3. Okay, suppose this is my sequence. Okay, so what I do now, I construct a new sequence, and how I construct that new sequence, I multiply by 2 with all the terms of this sequence. Okay, so I have some new sequence that is 2a, and that what is that sequence? So this 2an is nothing but 2 times n square plus 1 by n square plus 3. So limit of this sequence, limit of this new sequence is nothing but 2 times limit of this sequence. What is limit of this sequence? What is the limit of this sequence an, which is n square plus 1 by n square plus 3?
One.
How?
Divide numerator
Both sides.
by n square.
Correct. So an is what? An is basically n square plus 1 n square plus 3. Now what I do, I divide n square by both numerator and denominator. Okay, so what I'll get now? I'll get 1 plus 1 by n square, 1 plus 3 by n square, right? So as you can see, as n goes to infinity, if n if n is too large, then this thing, this 1 by n square goes towards 0, and 3 by n square goes towards also 0. So finally this whole thing will come closer and closer to 1, right? So that's why the limit of an is 1. So now I can blindly say that the limit of 2an is 2, which is nothing but 2 times limit of this original sequence a. Okay, so, and again the same thing, like for 3 is basically so in 1 basically we have discussed about the sum of 2 sequence, and 3 actually we are talking about the difference of 2 sequence. Okay, so 3, what 3 is saying, if the limit of the sequence an is a and limit of the sequence bn is b, then I can construct a new sequence. How? I'm taking the difference of both the 2 sequence. So this is nothing but an. Can you mute? Okay, I'm getting. Yeah, thanks. So this new sequence, I'm getting new sequence an minus bn. So this new sequence will converge to a minus b. So a minus b is basically the limit of this new sequence. Okay. So just like we have discussed about the sum of T sequence. So same thing goes with the difference of two sequence. Okay. So the next thing is the product of two sequence. Okay. So again, like this few property, they're useful to solve some complicated problems. Okay, if you know, so the only thing is you have to understand how you can apply all these things to a complicated problem. For that, you have to do few questions. Okay. Okay, so similarly, if I have, let's say, two sequence AN which converges to A, and another sequence BN which converges to B, then the product of this sequence, which is basically AN times BN, is nothing but A into B. Okay, so so for example, you take this sequence AN. Just now we have proved that this AN, so this sequence n square plus 1 by n square plus 3. So the limit of this sequence is 1. So my AN is now n square plus 1 by n square plus 3, and this limit of this sequence is 1, right? And what I do, I consider another sequence Bn, which is nothing but this sequence 1 by n. Okay, so this Bn is 1 by n, and we know that limit of this sequence is 0, right? So now if I have to consider this new sequence An times Bn, which is nothing but 1 by n into n square plus 1 by n square plus 3. So by using this rule, what I can say, that limit of this sequence is 1 times
1
0,
into 0,
which is 0, right? So the limit of this sequence, this A times An into Bn is basically 0. Okay, so it's saying the limit of the product is basically product of the limits. Okay.
Sir, I have a question. The second one should be 1, right? How can it be 0? 1 into 0?
Which one?
N square plus 1 divided by n square plus 3. That's 1, right?
Okay, so I have, this should be 0 times 1.
Oh, okay, yeah.
Okay, so now I have, so this is a quite useful property of limit. So what basically it's saying, so suppose I have a sequence AN. So suppose I have a sequence AN, and the limit of the sequence is A. And at the same time, suppose I have a polynomial function f. So if I have a polynomial function, let's say, so this is true for any arbitrary polynomial. Let's take a quadratic polynomial. Okay, so we have some quadratic polynomial 2x plus 2x square plus 3x plus 5. Okay, so I have a sequence and I have a quadratic function. So using this quadratic function and using this sequence, I can construct a new sequence, right? How I can construct? I have a new sequence. What is that? F of A. And what is f of n? F of n is nothing but 2n square plus 3an plus 5. Okay, and this property says this new sequence, the limit of the new sequence is nothing but f of a. Okay, so as you can see, this is a completely new sequence, right? The first, what is the first term of this sequence? 2a1 square plus 3a1 plus 5. So this is the first term. Okay, this is the first term of this new sequence. Okay, and the second term of the sequence is 2a2 square 3a2 plus 5. Okay, this is the second term of the new sequence. Okay, and so on. Okay, so this new sequence, so for this new sequence, if once you know the limit of this old sequence an, then it's really easy for you to compute the limit of this new sequence. Okay, if you know the limit of this old sequence, then it's pretty easy for you to compute the limit of this old sequence. For example, you take suppose you have a function. So can one of you tell me some example of some convergent sequence apart from the sequence I have already discussed?
X square minus cx minus 7.
No, I'm not asking about polynomial. I'm asking about some example of some convergent sequence.
By n squared.
Sorry?
1 by n squared.
That already I have discussed. 1 by n square is a convergent sequence. I'm asking something new.
2 minus 1 upon
That
n
is
squared.
1 plus 2 by n square.
Sorry, can you repeat?
1 plus
2
2
minus
by n square.
1 plus
2 divided by n square.
1 plus 2.
Only 2 denominator n square. Huh?
Yeah. So this is a convergent sequence, right? This is a convergent sequence. Correct?
Yes, sir.
Yes.
So what is the limit of this sequence?
1.
1. Yes, correct. So suppose you take some polynomial f of x, which is, let's say, x square plus x plus 1, right? So now I can consider a new sequence, right? So this is my an. So what is my new sequence? What is my new sequence? F of n. F of n is nothing but 1 by whole square plus okay, so this is nothing but 1 plus 4y divided by 4 by n square plus 2 by n square plus 2. Okay, so this I can write, if I do, I can write here 3, and this I can write this is nothing but this, right? So this is the new sequence, and I can easily say that the limit of this sequence, this limit of the sequence is nothing but f of 1. Okay, what is f of 1? What is f of 1? So here, as you can see, this limit, the limit of an is a, and which is nothing. So limit of the new sequence is nothing but f of a, which is same as f of 1. And what is f of 1 here?
It is 3. 14.
It's 3. Okay. So this limit of the new sequence is 3. Okay. Is it clear?
Yes, sir.
Okay.
Sir,
Hmm.
sir, I have few doubts in this practice question. So may I ask them right away or at the end you will discuss?
And yeah.
Okay.
So in the end you can ask.
Okay. Thank you.
Okay. Okay. So the next thing is. So now we have discussed about the product of the sequence and difference of sequence.
Sir,
at
sir, in this equation, the answer should be 13, I think. Fa, the limit of Fa. An.
So you are saying the answer should be 13. Why?
So F1. So we have to put the value 1 on.
F
So
of
I'm
1.
confused.
F of 1, right?
Yes.
But what is F here?
Okay. Okay. Sorry.
So this is a new F. So don't consider this previous one. Okay. Even if you consider the previous one also, you'll get some. You won't get 13. Okay. So here the f of x is basically x square plus x plus 1. So once you put x equal to 1, you will get 3. Okay. So this is what we are getting.
Okay, sir. Okay.
Okay. So okay. So basically, till now we have discussed sum, product, and difference of sequence. So the next thing is the quotient of two sequence. Okay. So the next property is quotient of two sequence. Okay. Suppose you have two sequence. Suppose you have two sequence and the limit of the sequence is A, and you have another sequence Bn, and the limit of the sequence is B, with some extra assumption that B is non-zero. So we have to assume that B is non-zero. I have two sequence A and the limit of the sequence is A, and I have one more sequence Bn, and the limit of the sequence B, which is non-zero. Then the limit of the quotient, that is An by Bn. So this is a new sequence. Then the limit of this new sequence is nothing but A by B. Okay. So for example, if you want to see this one, you suppose you take this sequence. So here we have considered this sequence, right? An, which is n square plus 1, n square plus 3. Okay. So if you want to apply this, so suppose, so here we have this sequence, right? N square plus 1, n square plus 3. So this I can write. So this I can write as 1 plus 1 by n square, right? And 1 plus 3 by n square, right? So now suppose my first sequence An is nothing but 1 by 1 plus n square, and the second sequence Bn is nothing but 1 by 3n square. Okay. And as you can see, this An converges to 1, right? And this Bn converges to 1, right? So then this An by Bn, which is nothing but n square plus 1 by n square plus 3. So then this will converge to A by B, which is 1 by 1, which is nothing but 1. Okay. So you have to split accordingly, like suitably. If you split the sequence, then it will be easier for you to get the limit of that sequence. Okay. So it sort of depends how you are splitting that sequence. Okay. So next. So the next thing is. So the next thing is you have this properties. So so this is so if you take, so in some sense the limit of the sequence preserve the exponential. So it's basically this 7th property is saying, so the limit of the sequence sort of preserves the exponential. Okay. So suppose you have a sequence An. Okay. Suppose you have a sequence An. And you know the limit of the sequence, which is A, and you take any real number. So now using this real number, And using this limit, you can consider one more sequence. What is that sequence? The exponential sequence. That is C power an. Okay. So the limit of this new sequence, is nothing but C power a. Okay. So before this taking this limit, you have to make sure that C power an is defined for each an. Okay. For example, suppose you have a sequence, let's say suppose you have a sequence -1 by n. Okay. And this sequence converges to 0. And if you take some number, maybe -2, which is in R, then basically -2 power 1 by n, it's not defined for each n.
It will go in complex.
Yeah. So you have to make sure that when you are taking C power n, so you have to make sure that this C power an is always in R. Okay. So you have to make sure before taking the power, you have to make sure that the C power an is always inside R. If that sequence is not inside R, then there is no point of talking about the. So then actually, yeah. So then you should not consider that C power a is the limit of that sequence. Okay. So otherwise, if this C power an, if that C power an is in R, then this limit of this sequence is nothing but C power a. Okay. So for example, if you take, let's say,
Sir, can you repeat line 1 and 2?
Line 1
this sheet and 2 of this sheet. It takes C element of R, -2 element of R.
But -2 power 1 -1 by n, it's not in R, right?
Yes.
It's a complex number, right?
Yes.
So in that case, we cannot take C power an. Okay. So when you are taking C power an, you have to make sure that C power an is always inside R. Okay. So if C power an is always inside R, then I can say that the limit of this sequence is nothing but C power a. Is it clear?
Okay.
So for example, if I take this sequence 2 power 1 by n, okay, so this is, so here 1 n is basically 1 by n. Okay, so the limit of this sequence is nothing but 2 power limit of this an, which is 0. This is nothing but 1. Okay.
Okay, sir.
Okay. So the next one is again the same thing. The log preserve the limit. Okay. So here, suppose you have a sequence an which converges to 0. Sorry, not 0, which converges to 1. And one more condition, that each term of the sequence is positive. Okay. Then the limit of the new sequence, how I get this new sequence? By taking the log. Okay. So let's say you can take any base. Let's say base is m. So the log of an, limit of this sequence is log n a. Okay. So for example, if I take this sequence, what is the limit of this sequence?
1.
1. This sequence, this is my sequence.
0.
This is
Zero.
this will converge to what is an here? What is an here? An is what? 1 plus 1 by n, right? What is the limit of an? Sorry? 1.
1, sir.
1. So then the limit of this log of 1 plus 1 by n will be log 1, right?
Yes.
Which is 0.
Yes, sir.
Okay. So the limit of this sequence is nothing but 0. Okay. So in some sense, it's saying that log preserves the limit. Okay. So if you have a sequence an converges to a, then log of an will converges to log of a. Okay. Okay. So and the next and the last property. Okay. So again, I'm saying these. So these are quite helpful property. So you'll see similar kind of property in limit, in continuity, in differentiability. Okay. So the next one is, suppose you have two sequence an and another sequence bn. Okay, and limit of both the sequence are same. Okay, so let's say n converges to, let's say, alpha and bn converges to alpha, right? So the limit of both the sequence, they are same. Suppose you have one more sequence cn such that cn is always in between an and bn. Okay, suppose you have one more sequence such that limit cn, all the terms of the sequence, so basically c1, saying c1 is in between a1 and b1, c2 is in between a2 and b2, then it's saying, so if similarly for all the terms of cn, then it's saying that limit of, so limit of cn is also alpha. Okay. So
how can
sorry,
how can we prove that in this case?
No, so the thing is what? See, if you see this, so it's not. So I'm not saying anything profound. If you see what basically it's saying. See an, so my bn is less than cn, which is less than an. Okay, so I know that an and bn both converges to alpha, right?
Yes.
That I know, right? So if I increase the value of n, okay, it will come closer and closer to alpha.
Right.
If I increase the value of n, then an will come closer and closer to alpha, right? And cn is nothing but it's basically in between bn and an. Right?
It's logically correct. Yes.
Then cn has to come to alpha if I increase the value of n, right?
Yes, of course.
So in some sense, I'm not saying anything. So to see the thing is, to prove, you have to prove it. Like if you want to prove, then you have to prove it mathematically. Okay, so that actually, see, the main thing here actually in this, if you see in this course, basically we are not giving you the precise definition of the limit. Okay, so there is a precise definition of the limit. So once you know the precise definition of the limit, then actually you can prove this. Otherwise, you can't. Okay, so then I have to say it vaguely.
Okay.
Okay, so so all this property are now clear to you, right?
Yes, sir.
Okay. Okay, so the next thing is we want to calculate some limit of few functions. So so and we want to validate which of the following option are correct or not. Okay, so some options are given. So suppose so here so the first option says that limit as x tends to -1, so the limit of this function is -1. So whether the first option is correct or not, anyone wants to give the answer? How? So basically I want to ask like how I should approach this question. Suppose this is given, so how I should approach this question to find out the limit of this function.
Factorize.
Sorry,
By factorizing.
Sir, first we can divide
No, sir, first we
numerator and
can check,
denominator
sir.
and find their separate
check for
limits
minus
and
one,
then
two.
an by bn.
yes, correct. Okay, so can you okay, mute? Yeah, so the first thing is okay, so the first thing is you should check whether the thing what you have in the denominator, whether it vanishes at that point. Okay, so if that vanishes at that point, then you need to factorize it, or whether then you have to go further. Otherwise you can simply substitute this -1, this -1 in both your numerator and denominator. Okay, so first we need to check. So first, when we are computing this, so we want to compute this thing, right? So
denominator will be 0, sir.
The denominator will vanish.
Yes,
correct. So if I substitute the -1 in the denominator, what I'm getting, it's basically I'm getting 0. Okay, so then I can't simply substitute the value. Okay, so I have
Factor it, I guess.
Factorize.
Yes. So what will be the factorization?
X squared minus 7x plus x
Plus x minus 7.
Sorry, just 1%.
X minus 7
x
by
squared.
You are talking about the denominator or numerator?
Numerator.
Numerator is what?
X squared minus 7x.
No, you are.
So direct factors we can write x minus 7 and x plus 1 for numerator.
Yes.
Minus 7 into
X plus 1.
Yes.
Divide by x plus 2 into x plus 1.
Okay. So now since this this -1 vanishes, so if I substitute -1 in the denominator, so I'm getting 0. So then I cannot simply substitute -1 in both denominator and numerator. So what I did, I tried to factorize both the functions. So finally what I got, so the say x square minus 6x minus 7 is nothing but x minus 7 into x plus 1, and the denominator is nothing but x plus 2 into x plus 1. So now what I can do, I can cancel these two things. Okay, since see it's basically saying x tends to -1. Okay, so it's basically saying x is coming towards -1. Okay, it's so that means x, so in some sense it's saying that x is basically, it's not -1, but it's very much close to -1. Okay, so if x is not close to -1, okay, if x is not close to -1, sorry, if x is not -1, then x plus 1 is not equal to 0, right? see, x tends to -1. So basically it's saying that x is very close to -1. It's saying that x is very close to -1, but certainly x is not equal to -1. So if x is not equal to -1, then x plus 1 is not equal to 0. That means I can cancel both the things, right?
Yes, sir.
So
Sir,
then
this is to remove the component where this function becomes invalid, right?
correct. So now I can simply so now I'm in safe situation. Okay, now I can simply substitute the value. So if I substitute the value, what I will get? I'll get -1
-8 by -1 by 1. -8 by 1 -8.
Yeah, so
-8
basically
by 1.
minus.
So this is true.
Yeah, so this is true. Okay, so okay, so let's go to the next one. Okay, so I'll do
False.
This will not be true because x tends to 0.
Yeah, just a
Will
minute.
not return that value.
Yeah, just a minute. Yeah, so the next one is, let's
It is
say
the same expression.
2. This is the same expression. Okay,
Yeah,
so
it is
then
wrong.
there is okay, so again it's pretty easy. So now basically we can substitute the value. As you can see, x square minus 6x x square minus 6x minus 7, and the below one is x square plus 3x plus 2. So first thing we need to check whether this both the function in whether this function in the denominator, whether it vanishes at 0 or not. But if you substitute 0, what you will get? It's basically 2, right?
Yes.
That means the function in the denominator doesn't vanishes at 0. So then I can simply substitute 0, this x to be 0 in both denominator and numerator to get the limit. So this is nothing but this is basically 7 by 2. Okay, and the third option is pretty easy. So what you need to do, you need to just, so this is a polynomial function, right? So this one is a polynomial function. Okay, so to get
this
the,
is true.
so to get the limit, what you need to do, you need to substitute
the value of
value of the
is
x
2.
in this polynomial. Okay, and
Yes, then it will be fine.
yeah, and what about
But if it becomes 0, sir, then we have to factor it. No?
which one?
The
This
fourth
third
one.
No, third one you don't have to factor it, because the main problem is what? When you are getting 0 in the denominator. Okay, so basically, so you can, if you substitute directly here, so then you will get some number divided by 0.
Yes.
Okay, so then you are in trouble. Okay, so then you have to make sure whether you can cancel some factor. Okay, but here you don't have anything, like if you
in
see
denominator.
Here you have 1, right? So 1 doesn't vanish. Okay, so then you don't have to worry. You just have to simply see, this is what basically you have 1 in the denominator and this polynomial function in the numerator. Okay, so basically what you are doing, if you substitute 2 here, so 1 is a function, right?
Yes.
Even you can think 1 as a function. This is a constant function.
Yes.
Okay. So then if you substitute 2 in both numerator and denominator, what you will get? So here in the denominator you will get 1.
You will
right?
not get anything. It will
you basically will get 1. So the main concern is you are not getting 0. Okay, right? That is your main, that should be your main concern, whether you are getting 0 or not. Okay, if you are getting 0, then you need to factorize it, and then you need to cancel some of the factor. Okay, if you are not getting 0 in the denominator, then you simply substitute the value. Okay,
Okay, sir.
and similarly you can try option 4. right? So it's, I guess it's basically what it's
X minus 3 whole square.
whole square. Okay, so if so this is nothing but x minus 3.
This is false.
Whole square. So then this is nothing but limit extends to 3 x minus 3, right?
Yes, sir.
So this is 0.
Yes, 0.
Yeah. So okay. Okay, so so the next question is, so this is one graph is given. Okay, so this graph is given. So so we need to check each option one by one. So which of the option is correct for this graph? Okay, that is what we need to check. So the first option says the limit of the function as x tends to 0 is 1. Okay, so basically what it's saying, it's saying that as x tends to 0, the value of the function is what?
1.
1.
So that means it's saying that so limit means the left hand limit. The left hand limit is also 1, and the right hand limit
Also 1.
is also 1. Okay, so now if you see, if you're, so this is your x, right? This is your x axis, right? And this is your y axis. So now if you see so this is basically saying the right hand limit is 1. So it's saying as x approaches to 0, so when you are coming towards 0 from the right hand side, okay, it's saying the value of the function is approaching towards where? 1. But this is not true, right?
Yes.
When you are coming towards 0, the value of the function is approaching towards
0.
0, right? The value of the function is approaching towards 0. So that means your right hand limit is 0, right? And similarly, if you see the left hand limit, when you are coming towards 0 from the left hand side,
It also
It's also 0.
the value of the function is also approaching towards 0. That means the left hand side is also, left hand limit is also 0. Okay, so that
for the every point we have to check from the both sides, right?
Sorry,
For the every point we have to check from the left and the right side, both sides. It is
no, I'm saying it more generally, since as from the first case itself you can say that this option is incorrect, because see, the left hand limit is 0, right? So sorry, the right hand limit is 0, right? That means the limit cannot be 1, right?
Yes.
That means from there itself you can say that option 1 is incorrect. You don't have to go to the left hand limit. Okay, so for your convenience, actually I did both the cases.
Second one is true, sir.
Yeah, so then 1 is incorrect, right?
Yes, 1 is.
Yes.
That means option 2 is correct.
2 is.
Yes.
Okay. And similarly, you can, so here basically what we got, both left hand limit and right hand limit, they exist,
Yes.
right? And they are same. They are same, right? That means limit
at 0 exists.
Limit at x equal to 0 exists. That means option 3 is incorrect. Okay. So the fourth option says there is a unique tangent. There is a unique tangent at x equal to pi. Okay. So here, so it's saying there is a unique tangent at this point.
This thing I'm not able to understand. This unique tangent.
Yes, sir. Can
Yeah,
you
so
please elaborate?
the problem is, well, what is the problem here? So you can have multiple tangent when the graph, when you have a corner in the graph. Let me do it more precisely.
If it is a smooth, then it will have a unique tangent, maybe.
Okay, so so if you consider this graph, let's say you take this graph. So this is, suppose you take this function. Okay, so the graph of this function is, let's say, this. Okay, I'm drawing only on the positive x-axis. Okay, so suppose this is the graph of the function. Okay, so as you can see, here you have a corner, right?
Yes, sir.
So here you have a corner. So at this point, you can have multiple tangents. For example, if you take this line, if you take this line, if you take this line, this line, if you draw this line, okay, this is also a tangent at this point. Okay,
It's overlapping.
Okay, so again, if you draw this line, another line, so this line, this is also a tangent at this point. Okay. So basically, when you have a corner on the graph, you can have multiple tangent. Okay, so basically, when you have multiple tangent, okay, so you'll see in next week, when you have multiple tangent at some point, we say that we say that tangent at that point doesn't exist. Okay, because we want this tangent to be unique. Okay, so so you can see, right? So when you have a corner point on a graph, then actually you can plot multiple tangents. Okay. But if the graph,
sir, I have a question
just a
related
minute,
to this.
I'll come to that. So when the graph is smooth, for example, if the graph is something like this, okay, if the graph is something like this, then you will have a unique tangent at this point. Okay, you cannot have multiple tangents at this point. Okay.
That means mod x, that is mod 1 has multiple tangents.
At 0.
At
0. Because see, here, if you see, so mod x has a corner point at 0, right?
Yes. Yes.
If you consider other points, then at those points it will have unique tangent. Okay, but if you only consider, see the tangent, see for different point you will get different tangent, right? So for example, if I take this graph, okay, so at this point, this is a tangent, right? But if I try to draw a tangent at this point, okay, I'll get a different tangent, right? So
yes,
it's depend on the point. Okay, at which point you want to draw the tangent. Okay, for mod x, if you consider this mod x, so at 0 you have multiple tangent, because this is a tangent as well as this is also a tangent. Okay, but instead of that, if you consider only this point, at this point it has unique tangent. This is the only tangent. This one is the only tangent at this point. Okay, so it's depend on the function and as well as the points. Okay, at which points you want to talk about the tangent. Okay.
But sir, I got a question here.
Yes.
For how I do it is, if I take any of these lines, or let's say the graph which you were showing, if I see the slope is equal on both the sides, then it's an unique tangent. From straight line,
yeah. So
from the straight line principle,
okay,
you can see in the mod x you have two different straight lines, so the slopes are different, so it should not have.
So basically that is what you'll see in the next week. Okay, so to talk about the slope, so basically see that if the function is basically differentiable, then basically you will get a unique tangent. So that we'll see in the next one. Okay, so as I said, now we are doing it vaguely. Okay, so tangent, so basically you will get a unique tangent if and only if that function, whatever this function, it's differentiable at that point. So you will see that this mod x is not differentiable at 0. Okay, that's why it has multiple tangents. Okay. Okay, so so as you can see now,
sir, one question in this, because this is a continuous function, right? So like in case when function is non-continuous kind of step.
No, this is continuous function. Mod x is continuous function. Okay, so continuous.
But in other case, like some functions which are not continuous at some particular point. So in that case,
yeah. If you have some kind of jump or some kind of corner, then that function, then you'll have multiple tangents. For example, if so this greatest integer function. If you consider the greatest integer function. Okay, so the greatest integer function is something like this, right? So you have jump. Okay, so so you have
it's very slightly
graph is something like this, right?
Yes sir, exactly.
So in this case, for example, at this point, okay, at this point you will have multiple tangent. Okay, at this point, let's say this, so this is 1, right? So at 1 the value of the function is 1, right? So at 1 you will have multiple tangent. Okay, this is,
okay,
this can be a tangent. Let's say this can be a tangent. Okay, you can have, this can be a tangent. You can have multiple tangents. Okay, so yeah, so basically if you have some kind of corner point or some kind of jump in the graph, okay, at those points you will always have multiple tangents.
But sir, in the same example, like suppose I have point 1.5, then at that point it will be unique tangent.
Yes.
Can we say that?
Yes,
or
at 1.5,
point like that.
Yeah, so suppose you are taking 1.5. Okay, if you take 1.5, so in that case you will land somewhere in the middle, right?
Yes.
Okay, then in this case you have unique tangent. And what is that tangent? This line is precisely the tangent.
That line itself, y equal to 1.
Yes. So basically what the main thing is, if in the graph, if you have some kind of jump, so here you have some kind of jump, right? So this is not continuous, right? You are coming up to here, from you are coming to, then you are making a sudden jump. Okay, then after coming up to here, then again you are making sudden jump. Okay, so in that case, so at the point where you are making this sudden jump, at those points the function will have multiple tangent. Or if you have something, if you have some kind of corner point, for example here mod x, here you don't have jump but you have corner point. Okay, so in those points you will have multiple tangent. Okay, is it clear?
Okay sir.
So
yes.
Again, I'm not giving you any proof. Okay, so once you know the differentiability, then you will understand, you not, yeah, so you will able to appreciate it more. Okay, so there actually we can explain you like this. So basically when you are taking limit, so you are, so the, as someone said, so if you approach from this side, you will get something different, and if you approach from this side you will get something different. So if you approach from this side, precisely you will get the slope of this line. Okay, and if you approach from this side, that is the right hand derivative, you will get the slope of this line. Okay, and if you compute the left hand derivative, you will get the slope of this line, and slope of these two lines, they are different, and that's why the derivative basically doesn't exist. Okay, so we'll see in the next. And And so the next thing is, as you can see, this option 4 is correct, right? Option 4 is correct. The option 4 is not correct. Okay,
Not correct, sir.
it's saying there is
Option
a
4 is not correct. 5 is correct.
there is saying that there is a unique tangent at pi. Okay, that is correct, because this here you don't have any jump, or also you don't have any corner point. It's a smooth curve. So at pi, this is the tangent. Okay, this line is basically the tangent. Okay, this y equal to 0 line is basically the tangent at pi, and at minus pi, same line y equal to 0 is also a tangent at minus pi. Okay, so my y equal to 0 is tangent both at pi and as well as at minus pi. Okay, so that's why option 4 is incorrect, but option 5 is correct. Okay. What about option 6? Because this is more or less increasing function.
So monotonically increasing means?
It's an increasing function.
Directly increasing.
That is a different. So it's a different way of saying increasing function. Okay. Increasing function and monotonically increasing function. That's
so sir, can we say that like monotonically increasing means it is increasing in that particular given interval? Is
yeah. No. You can see, you can specify anything, and you can say like the function is. See here, you want to check whether this function is increasing. So don't confuse monotonically increasing and increasing. They are the same thing. Okay. So here question in option 1, they wanted you to check whether this function is increasing in this interval or. Okay.
Sir, what is the difference between monotonous increasing and strictly increasing?
Sorry?
Is there is monotonous increasing and strictly increasing is same?
No. Monotonous increasing and strictly increasing, they are not same. Okay. There is a difference between increasing and strictly increasing.
How can they differentiate?
So increasing says
the y values can be equal, but in strictly increasing, the y values will always increase.
Yes, it says if x is less than equal to y, this is actually increasing, then f of x is less than f of y. Okay, this is increasing. Okay, what is the strictly increasing? It says if x is strictly less than y, then f of x is strictly less than f of. Okay, so there is a difference. If x is bigger, y is bigger than x, in strictly increasing function says if y is strictly bigger than x, then f of y should also strictly bigger than f of x.
Okay, sir, understood.
So there is, that's why we're using some strictly increasing. Okay. And
sir, I have one question in this unique tangent portion which you explained just now.
In this question, or you have from assignment or something?
Yes, in the last one. No, in this same question, we were discussing this now unique tangent at point pi and minus pi. It is having unique tangent, right? So like suppose I want to say something about any point in between this point 5 pi and 1 pi. So in that case, we can say that it is having unique tangent.
Yeah, because
the curve itself.
Again, see, the main thing I have already said, if you don't have any kind of jump or corner point, then you will have unique tangent.
Okay.
So
so it is universally correct sentence, right?
Yes.
Statement.
It's a universally correct statement. Okay. So as you can see here, in between them, there is no corner point or no jump. Okay. Then the tangent at that point exists and it's unique. Okay. So it's option 6 says it's monotonically increasing in this interval, minus 0.5 pi to plus 0.5 pi. Okay, which is incorrect, right? because
Correct, sir.
because as you can see, up to -5 to 0, the function is decreasing, right? And again it start increasing.
Increases.
Okay, so then certainly it's not monotonically increasing. Okay. So option 6 is incorrect. Option 7 says the function is monotonically decreasing in that
Also
interval,
incorrect.
which
Again
is also
incorrect, sir.
incorrect, because from -0 to 0.5 pi to 0, the function is actually decreasing, but after that it's actually increases. Okay, so if I change this question from this to this, 0.5 to 0, then option 7 is correct. Okay. Okay.
So just to be clear, so monotonically decreasing means strictly decreasing.
No, monotonically decreasing means not strictly decreasing. It means only decreasing.
Okay.
So when I say so for strictly decreasing, you have to mention that word strictly. Okay. Monotonically increasing means only increasing. Okay. Monotonically decreasing means only decreasing.
Okay.
Okay.
Thank you.
Yeah. Okay. So this part is clear, right?
Yes, sir.
Okay. Okay. Okay, I guess I will discuss. So this will be my last question. So after that, I will take your question. Okay, so Punendu.
Sir, my question is related to tangent and some of the sine and cosine functions. I will ask it in last.
Okay, fine. Okay, so the question. So here the question is, you have bunch of information which is given. Okay, so you have 3 information. So for the first one says as limit extends to 0, sin x by x is nothing but it's 1. Okay. So this is the first information, and the second thing is as x tends to 0, limit of this function. So this function is nothing but log of 1 plus x by x, which is 1. And the third one is limit of this function e power x minus 1 by x is 1. So you have these 3 information, and using this information you need to find the values of the following limits. Okay, just a minute. Okay, so you have these 3 information. Okay, so using this information you need to find the limit of, you need to verify which of the following option is correct. So what is the first option? First option says limit x tends to 0
log
sin x. It says whether this is 2.
So there's also 2 out.
This is wrong. This is 1.
Yeah. So how actually how you should try to find
log 1 plus x by a sin x by then 1 by 1 is equal to 1.
Yeah, correct. So something is given here, right? Sin 1 by sin, so sin x by x is given, and log 1 plus x by x is given. So now in this question only log, so if you see closely, then only you have here log 1 plus x and sin x. So in both the expression, this x term, the x term in the denominator is missing, right? So for that, what you need to do, you need to rearrange the function. Okay, so how you can do? You can write this as log 1 plus x by x into x by sine x, right? Right?
Yes, sir.
This
Yes,
is
sir.
so now I know the limit of this one because it's given, right? I know the limit of this one, right? It's given, it's 1. And I know the limit of this one, right? Some basically you can write this x by sine x as 1 by sine x by x. Okay. So so then what I do, I'll multiply, I'll take the product of the limits. Correct? And this is nothing but this is 1, and as well as this is 1. So we are getting 1, right? So that means this limit is 1, right? And okay, so I guess I missed something. So here you have some 2 is there, right? So as you can see, so in the first option, 2 times this, right? So
Then it will be 2.
So then if I write 2 here, this is nothing but 2 times limit of this limit, which is nothing but 2, right?
True. This is true.
Yeah. So then option 1 is correct. And since option 1 is correct, then I can say that option 2 is certainly incorrect. Okay. And what about option 3? Sine 3x by x. So option 3 says, okay, I need proper explanation for this question, not only answer. Sine 3x by x is 1. Okay. So how we can compute the limit of this?
Sine 3x by 3x, then we multiply
so we
into
will multiply
3.
and divide by 3.
Okay, so then
Sine 3x by 3x into 3.
So only thing we know, so only one thing we know, which is given. It is given that sine x tends to 0, sine x by x is nothing but 1. So using this, we need to compute this. Okay, so what we are doing, we are dividing by
3x.
We're dividing by 3. Then it will be 3x.
So we are dividing by 3. That means we have to multiply by 3, right?
Yes. Then it will be equal to 3.
No, why?
Because 3x is a subsequence of x. So
Sine 3x by 3x is equal to 1. This is subsequence of sine x.
It's not a
by
subsequence. The sine 3x is not a sequence. Okay.
We apply property C into n.
So what basically we are doing? Okay, so what basically we are doing?
So using L'Hopital rule, I think it will be easier.
Just give me a minute. Just give me a minute. Okay, so so now what we can do, so now we have this, right? Limit x tends to 0, sine 3x by 3x, right? So now what we do, we substitute y as 3x, right?
Okay.
So this is what we substitute, right? And if y tends to 0, then x tends to 0, right?
Okay.
If y is
Yes.
going towards to 0, that means
then x also tends to 0.
So if x tends to 0, then y also tends to 0, right?
Yes.
So this thing I can write as this thing. I can write as 3 times limit y tends to 0 sine y by y, right?
Yes.
sir.
Right. So basically now I am coming back to the original. Okay. Now I am coming back to the original. Okay. So then,
Okay. Now
then
got it.
basically it's nothing but 3. Okay. Okay. So that's why this I guess this is incorrect. Option 3 is incorrect.
3 is incorrect. 4 is correct.
4 is correct. Okay. And now can you tell what about option 5?
Same thing.
5th is incorrect.
That will be 5.
Yeah, it should be 5, right? So it's incorrect. Okay, so next, okay, so I guess option 6, 7, 8, 9, they are more or less similar. So I'll do one of them. Let's say take option 6. Option 6 is basically e power. Okay. So this we need to find limit x tends to 0 by 5x, right? So we know two things. So basically we are going to use two things here. Limit x tends to 0, e power x minus 1 by x, it's 1, and one, right? So we are going to use these two things. Okay. And how we'll use? So as you can see, so basically we have already solved a similar kind of problem. So here, so we just need to multiply x and divide x, right?
Yes.
Now, what is the limit of this one? What is the limit of this one? So this I can, okay, basically I know both the limit exist. That's why I can multiply it. Okay. Okay, this minus is here, not in the power. Okay. So my question is, what is the limit of this one?
We have to divide it by 5 with 5 mixed by 5.
Yeah, so
1 upon 5.
So
yeah,
this
it
is,
will be 1.
So this is nothing but 1 by sine 5x
Sine 5x
by x, and we know the limit of this sine 5x by x. This is 5, right?
Yes.
So that means limit of this one is 1 by 5, right? So this limit I know. So this limit, the limit of this one is 1 by 5. And what about the limit of this function? What about the limit of this function? So our next task is to find limit of this one. How you should find limit of this one?
So we will divide and multiply the denominator
divide by 5
with 5.
Denominator divide by 5, so it will be multiplied by 5 over.
Yes. So what we'll do now, this is nothing but x tends to 0 minus 5 x by 5 into 5, right? And this is nothing but,
yes, we can take it equals to y,
right?
1/5. Yes.
1 by 5.
so now by the same procedure, like you just need to replace x by 5 as y. Okay, so then if you do it, what you will get, limit of this one is basically 1.
1 by 5.
So eventually if you multiply 1 with 1 by 5, you will get 1 by 5. So finally what you are getting,
1 by 20.
1 by 5 square.
Yes, 1 by 5 square, which is 1 by 20. Okay. So yeah, so then similarly, like you can calculate the previous. I guess both are same. So
Option 8
option 8 is correct. This 7, 9 are correct.
Yes.
Okay, so yeah, so I guess I'll stop this session now. So if you have some, not stop, like
sir, I just have a doubt in this last
I'll
step.
stop.
Can you please slide down that?
Explaining this slide. I can take your question. Yeah. Sorry.
The last slide which we were calculating, I just have a small doubt.
Here.
Again, the down slide.
This one.
Further down, sir. Yes.
Hmm.
So, sir, I like what I understand is like if we will just substitute the
Yeah. I can't hear.
Yeah, that denominator. Sorry. Yeah, numerator it is having e raised to x by 5 minus.
I can't hear you. Sorry, am I audible?
Yes, sir, you are.
Okay, fine. Okay, so yeah, so okay.
I think
so
there's some network issue.
yeah, so okay, so I can start taking your question. So Devans.
Sir, can you please confirm whether the sequence in graded assignment 7 question number 10 is correct?
Okay. Question number 10. So no, it's correct. Yeah.
It's correct because the last sequence says 10 into n minus 5. If I put 1, I'll not get 15 and 25.
Okay. So what is your sequence? Can you tell me?
So yeah. So the sequence is 15.
15
plus 1 5 15 plus 25.
25.
Yes.
Just a minute. 25 we are getting. Okay, fine. 25.
Then it's plus 35.
35.
Plus dash.
Hello.
Sorry, I was on mute. In parentheses. 10n.
10n.
Minus 5.
Minus 5.
Fine. Upon n square.
Yeah. N square. Yes.
Yeah.
Yeah. So what is your doubt here?
So it says n should be greater than equal to 1, but for 1, it comes out to be 5.
Okay. So, okay, I guess that is not an issue, but yeah. So you assume that this 10n minus 5 is always greater than this first. Okay. So when actually, so the thing is, when I'm writing in the beginning, when I'm writing 15, that basically that implies that you have to consider such n such that 10n minus 5 is always greater than 15. So here basically n should start with 2. Okay.
Okay.
And again, like so the thing is when you are considering some sequence, see so if you change the first few terms of the sequence, then certainly it won't affect the limit of the sequence, right? So
Sir, in this one, in quotient it's given where n belongs to n.
Yeah. So that is incorrect.
And without 0. Yeah.
Yeah. This should be start with n should be greater than equal to 2.
2, right?
Yeah. Yes.
Okay. And even if we take okay. So where n belongs, that thing is not right.
Yeah. Where n belongs is not correct. And again, like so if you're considering, so if you're considering it from n 2 3 4, it won't affect the final answer. Okay. But whatever you are saying is correct. Okay. So for n equal to 1, you don't have, like, this expression has no meaning. Okay.
Yes. Okay, sir. Thank you for
yes. Okay, the next person is Punin.
Sorry, sir. One more question. In the graded assignment 7, there are few questions with 0.0. So, is it mandatory to attempt those questions? There are around.
Yes, sir. They are
3 to 4
mentioning it as 0.034 questions. So, are there any error or like?
I think there is no mark, like no error, I guess. Yeah, there is no mark for the question, I guess.
So, sir, I'm asking this question because if we start solving those questions, they will take significant time, right?
Yes,
but okay, so I'll suggest you to solve all these questions. Okay. So
okay,
yeah, so I can't confirm you now whether if you will not solve this question, like there is no mark, because it's saying 0 points, but I can't confirm you whether you will get any marks on these questions or not. Okay, so basically probably so what is the submission date for this question?
So it is tomorrow.
Tomorrow.
Okay, so I guess, yeah, so certainly now I can't confirm you. Okay, so maybe, yeah, but for this session, I'll suggest you for this particular assignment, I suggest you first you try to solve all the question where mark is mentioned. Okay. And after that, if you have time, then you try to solve the other question. Okay, but first you should give priority to the question where the mark is mentioned.
Okay. And one more question, sir, that the question I just asked where n belongs to n taken out 0. So in that question, I've seen sometime that we solve those question again. There is a reevaluation and the number is gone.
No, so
points are gone.
No, not points are gone. Actually, it's not that points are gone. We are simply ignoring that question. Okay, so in some cases, see, certainly many times we also prepare some incorrect question. Okay, so
I totally understand that. That there can be some spelling mistakes or writing mistakes.
Yeah.
So this question will be ignored in the final evaluation or not?
Yes. So certainly we are not going to calculate any marks for that question. Okay. So what happens after this after the submission date? Few students, they point it out. Okay. So after that we ignore all these questions.
Okay, sir.
So it will. So in the final thing, you can see that we have ignored that thing, and you will get the mark. Okay.
Okay, sir. Thank you.
Okay. Okay. Any other doubt? Punnendu Sukla, I guess. Okay. So Kajari Saha.
Yes, I'm telling about the activity question 7.5. The question is the question number 6.
Just a minute. 7.5. Question number 6.
All right. Fx equal to x square by mod x. This question. This mod X thing is really confusing model for me. How do these that level 2 questions? I'm not able to do
Just a
that
minute.
6, 7, 8.
Just a minute. Just a minute.
Okay.
Okay. So, so the question is f of x is nothing but x square mod
By
x,
mod
right?
X.
Right.
Limit x tends to 0.
Yeah, so that is the next thing. So first we need to split this function. Okay, so we know that what is the definition of mod x? Mod x is what?
Positive number, all real numbers, x for all real numbers, it will be return positive.
That is, but see, the thing is there is a definition. So mod x is
If x is less than 0, then
it is
okay.
It is x
greater
it is,
than 0.
Greater than 0 equal
and
to
minus x for x less than 0.
Okay, so I can split this function accordingly, right?
Yes.
So what I can write, f of x is x square by x if x is greater than 0, right?
Okay.
X square
by
minus x if x is
less than 0.
0. Certainly, so here you can see I cannot write x is greater than equal to 0 because then I'm in trouble. If
infinity.
If x is, no, then I'm actually basically I'm coming to 0 by 0 point. Okay, so that's why that's why I can't write that. Okay, so for that I have to do it write it in separately if x is 0, right?
Okay.
Okay, or whether it's given in the question. Okay, it's not given in the question. Okay, okay, so I really don't care. So I really don't care about the value of the function at x equal to 0. Okay, so so this is nothing but x if x is greater than 0, right?
Yes.
This is minus x if x is
less than 0.
0. Okay. So then what is the graph of this function?
It's the same as mod graph without value for 0.
Without the value of 0, so you don't have anything here. Okay, so you have a blank here, and apart from that, this, right?
Yes.
So now
excluding
you can
0.
now you can calculate the limit of the function at x equal to 0, right?
So we can also write, like, we know x square is always positive, so we can write x square as mod of x whole square. So therefore we will have mod of x whole square upon mod of x. So
Correct.
we will directly have mod of x, but x cannot be 0.
Yes, correct. Yeah, that is correct. Whatever you are saying is correct. So as you can see, if you are coming to 0 from the left hand side, right hand side, the right hand limit is 0. Okay. When you are coming from the left hand side, the left hand limit
is also 0.
0. So that means both the left hand limit and right hand limit, they are same, and the limit of the function at 0 exists, and this is precisely 0. Okay. Is it clear?
Okay. Yes.
Okay.
Then this question, consider the graph, the next one, 7 1.
Okay. Okay, so before that, let me draw the graph. Okay, so just give me a minute to draw the graph. Okay. So so yeah, so this point is included.
Yes.
This 0 point is included. Then you have at 100. So this is 100. So this point is not included. Okay. And you have 1 here.
1, yes.
And this one is not included, right?
Yes. Yes.
But this one is included. And the graph start from here. It goes like this and it's moved. Then it start increasing. Okay, so this is 2, right?
Yes.
This is 3. Okay, so now you start reading the option. So what is the first option?
Okay. First option is left limit at x equal to 0 is 0.
Left limit at x equal to 0 is 0. So do you have any doubt in this option?
No, no.
Because as you can see, if you are coming from the left hand side towards 0,
It tends to 0.
the value of the function coming towards 0. So now so the left hand limit is 0. Okay. So then what about the next option?
Limit exists at x equal to 1.
Limit exists at x
equal to 1.
Okay. So so for that, what you need to find to say whether limit exists at not. So you need to find the left hand limit
and
right hand limit, right? So
and how could I find that limit for 1?
Yeah. Just a minute. We'll compute. So as you can see, so let's try to compute the left hand limit of at 1. Okay, let's try to compute the left hand limit. Okay, so when you are coming to 1 from the left hand side, as you can see, where the value of the function approach. Sorry,
I'm not able to get it. That's enough.
No, what I'm saying, when you are coming to 1 from the left hand side, okay. So where the value of the function is moving?
1.
It is near.
No, it's
near
100.
To.
It's 100, right?
Near to 100. Yeah.
It's not near to 100. It's precisely 100. Okay. See.
Okay.
See, suppose.
But sir, that point is not.
No, suppose. So what do you mean by if the value of the if x approaches to 1? Okay. So if I consider some sequence from the right hand side, let's say this sequence 1 minus 1 by n, right? This sequence is coming to 1 from the left hand side, right?
Yes.
Now I have to check where the value of the this value of this value of this new sequence. So I'm getting one more sequence, right? This is one more sequence. I need to check where this value of this thing is going. Okay. See, this f of 1 minus 1 by n is always 1.
F of 1.
It's always 1. Oh, sorry, not 1. It's always 100. See,
f of 1 is always 100.
No. In this interval, okay, what is the value of the function?
It is 100. Yes.
100. So
yes,
so
100.
if I put n equal to let's say 1, what I am getting? What I am getting?
100.
F of 0, right?
Yes, f of 0.
100.
This is, let's say, 0. Okay, I don't care. Next n equal to 2. What I am getting? 1 by 2.
1 by 2.
Which is 100. Okay. For n equal to 3, what I am getting? 1 minus 1 by 3, which is 100, right? Right?
Yes.
Again, for n equal to 4, I'll get 100. So basically what I am getting, this sequence f of 1 minus 1 by n, it's going towards 100, right?
Yes.
This part is clear?
Sorry, sir.
No, what I am saying.
If f1 is equal to 100.
No.
That I get it.
No. So
I'm
the first thing is, we want to compute the left-hand limit. Okay. So when I'm trying to compute the left-hand limit, the first thing what I should do, I should check when I'm coming towards 1 from the left-hand side of 1, I need to check where the value of the function is.
Now I got it. Now everything
approaching.
is 100. This is the.
So when I'm coming to 1 from the left-hand side, for example, you take this sequence. So this sequence, using this sequence, I'm coming to 1, right? And I'm coming from the left-hand side, right? From the left-hand side of the 1. So at all the points of this sequence, the value of the function is 100, right? Apart from 0, which I don't, apart from 1, which I don't care. Okay, because after 2 onwards, the value of the function is always 100.
Okay.
So that means the value of the function is approaching towards 100, right? That means, so basically, in other words, what I was trying to say, so this actually I have taken a particular sequence, right? It doesn't matter what type of sequence you are taking. If you are coming towards 1 from the left-hand side, okay, then the value of the function is always 100, right?
Okay.
That means the value of the function is approaching towards 100. So in other words, it's saying if you are coming to x from the left-hand side, okay, then f of x
is equal to 100.
It's actually, it's in this case, it's exactly 100. So that means f of x is converging to 100.
100, yes.
That means my left-hand limit of this function at 1 is
100.
Correct?
Yes.
Okay. The same thing you apply for right-hand limit. Okay. So now if you are coming to from the right-hand side, okay, correct. When you are coming from the right-hand side, you can see the value of the function is approaching where? To this point, right? Some arbitrary point, but that is not 100. That is not
100.
Both limits are different.
Okay, so that is some point is there. Which I don't know, but one thing I know, that point is not equal to 100. Yeah. So that means the left-hand limit.
Left-hand limit is not equal. So one limit is not exist.
Yeah.
Does not exist.
So here the left-hand limit exists, the right-hand limit exists, but they are not equal. Okay.
Yes. That means the graph is not continuous.
Yeah, actually it's not continuous. So even so, since the limit doesn't exist, so that means it's not continuous.
Not continuous. Yes.
Because continuity implies existence.
Left-hand limit equal to right-hand limit. Yes. Okay. The limit exists at x equal to 2. This is not also true, right?
No, why this is not true?
No, this is coming from both sides. Yes.
So when you are coming from this side, from
this
when you are
tends to 2.
When you are coming from the left-hand side, okay, the value of the function is going towards
2.
0.
0. Yes, 0.
Again, when you are coming from the left-hand side, the value of the function is going towards 0. That means both left-hand limit, right-hand limit, they are same and they are same. That means the function has a limit at 2.
Okay. Got it. The limit exists at x equal to 0.
Limit exists at x equal to 0. So now what you can say?
Same logic as x equal to 1, right?
Is not equal to, because limit 1 tends to equal to 100, na?
No, you want to check whether limit exists at 0.
Yeah.
Right. So this is your 0. So so basically now what is your left-hand limit?
0. 0.
0, right? This is 0. What is your right-hand limit?
100.
Correct. The same argument what we gave for 1, right?
Same logic.
So because when you are coming from this side, Okay.
This will be 100.
Then you see the value of the function. So then basically you are coming towards this point, right? When you are coming towards 0 in the domain, in the range you are coming towards 100, right? That means the limit of right hand limit at 0 is 100 and the left hand limit is 0. That
So
means
limit not exist.
Limit doesn't exist. Yeah, correct.
Yeah. Okay. Then the limit exists at x equal to half, which is 100. This is true. Maybe this is half. This is 100, right?
This is correct, right?
Yes, this is correct.
Because okay, so because what you have now, I will draw. So this is your 0. This is your 1. Okay.
Yes.
And this is your half, right?
Yes.
So now you have 100, right? So as you can see, when you are coming from the right hand side,
this
the
is 100.
Value of the function is coming towards 100. Okay.
Yes.
So when you are coming from the left
Right
hand side,
left hand side, this is also 100.
100. So both left hand limit and right hand limit, they are 100. So that means the limit exists and it's equal to 100. Okay.
And the last one is also true. Limit is not true. Limit exists at x equal to half, which is 0. This is not 0. This is 100, right?
Since the above option is correct, yeah, that means
And one more question, last question, 10th number, last option. How to do that to find that limit?
No, you just need to divide x power 2021. Okay, in both denominator and numerator.
X power 2021. Okay.
Yes. Then see, this is nothing but something like this. Okay, so.
And this is a very big number, so I am confused.
No. So this is some x5, x4, okay, x square plus 1, right?
Right.
And you have here x5 plus maybe 2x4, 1, right? So what I'm doing, I'm dividing x.
But instead of 5, the limit will be, the value will be 1.
So then what I will get? It's basically 1.
1 by 1.
1 by x, okay. 1 by
x is 5, x cube plus 1 by x to the power 5.
This is what we are getting in the numerator, and similarly 1, 2 by x, 3 by
x cube plus 1 by x to the power 5. This term will be 0. Yeah. This is 1 by 1. This is 1.
1. Okay. Yeah. So this all this term they will go towards 0 as x tends to infinity. Okay. So you have 1 and 1 both in the numerator and denominator. So eventually you get.
Okay. This will be 1. Then the limit of this will be 1, right?
Yes.
Okay. Thank you, sir.
Yes. Okay. Any other question?
Yes, sir. I have a few questions.
Yes, please.
May I?
Yes.
Yes, sir. Activity 7.4, question number 1, 7, and 8.
7.4.
Question number 1. So, like, I am just having basic doubt in that why only option 2, like function f2 and f5 are the correct answers, and why not the others?
No, that is what I have. So this is, if you see in the beginning, what actually I have discussed. So what is sequence? Sequence is nothing but it's a function from the set of natural number to R.
Okay.
Right?
Yes, by definition. Yeah.
By that is the definition. Okay, and so in general you don't see sequence in that form. You don't see sequence when you see a question. You don't see sequence in the form of a function. Okay. In general, you don't see, right? Okay. You see it as a list of elements.
Yes.
Correct. So the thing is, when you have a list of element, okay. So when you have a list of element, A1, A2, A3, okay. This is how you see a function, right?
Yes.
So when you have a bunch of list of element, then actually from using this list of element, you can construct a function from the set of natural number to R. So how you construct? You take the image of 1 to be A1, image of 2 to be
A2.
A2, right? And similarly,
yes.
image of n is
Yeah.
A. Okay. So if you have a list of, so this is how you see a sequence, right? So if you have a sequence like this, you can construct a function from natural number to R, right?
So sir, this simply means that like the position, like first element will be always like we will start from 0 or 1. That's why we are starting this from natural set. Is it so?
Yeah. So since actually it's completely depend on the index. As you can see, you are actually starting with 1, right? This first index is 1. The second index is 2. That's why the image of 1 is A1. Okay. The image of 2 is A2. Okay. And similarly, if you have a function, right? If you have a function, suppose a function is given, which is from natural number to R, then actually you can create a sequence out of it, right? What is the first element of the sequence? This is nothing but the image of, this is f of 1, right?
Okay.
And the second element of the sequence A2, this is nothing but f of 2. And similarly, the nth element of the sequence, which is an, this is nothing but f of n. Okay, this is how you consider. So from the sequence, you get a function. From a function, you can get a sequence. So more precisely, sequence is nothing but it's a function from natural number to R. Okay. So the only confusion, if you see, so there are two functions which so in the option, if you see, so there are two functions which start from natural number. Okay, but one function ends in R and another function ends in Z, right? But the thing is, if you have a function from natural number to Z,
okay,
I can treat this function as a function from n to R also, right?
Yes.
Because Z is a subset of R.
Yes.
Okay. So then I can treat this function. Okay, I can treat this function from n to R, right? Because certainly Z is inside R, right? So that means F5 is also a sequence, right?
Okay.
Is it clear?
Yes, sir. Yes, sir.
Yeah.
Sir, option, sir. First, why R2 are not concluded as the function, sir?
Sorry?
Why R2 are not concluded as a function, sir?
It's not a function. It's R2R is a function.
Domain
it's not.
Cannot be R, right?
It's a function, but it's not a sequence. That is what I said, right? It's a sequence is a function from n to R, natural number to R. But in the first option, you don't have n in the first option. You have R in the first option.
Okay.
Yeah.
Yeah. So then the second question, sir, is question number 7 and question number 8 in the same practice.
7. Okay, 7 is pretty easy. It's basically you need to rewrite the sequence. Okay, so just let me do it. So what is the sequence? An is what? Is 2n?
2n plus 1 whole root.
Minus 2n, right?
Minus 2n, yes.
So what you do, you try to multiply this plus, means basically what I'm doing, you multiply.
Okay.
It's a rationalization.
Yes.
Okay.
Now you can see, right? This is nothing but 1 by. So that means it will converge to 0, right?
Yes. Okay, got it. Yeah.
Okay, so.
And the next one, sir, 8th one, I am clear with the first option, but clear with the second option as well. I am just having doubt in the third option, log 1, log 2 minus 1.
Yeah. So what is the third option? This is so you need to find, so limit n tends to infinity
ln 2 minus 1 by n.
ln 1 plus n power 1 by n, right?
Yes, sir.
So if you see now, if you go and see the property, so here you can see a property of law of sequence. So as you can see, so if you see the eighth one, so it says if an converges to A, then
And then
log an
converge to log A.
Log A, right? So we are going to basically apply this one.
Okay.
So basically, as you can see in this one, the whatever is there in the denominator. So 1 plus n to the 1 by n, right? So this will converge to 2, right?
This will converge to 2.
Because it's in the question, it's, I guess it's given that this limit, the limit of n.
Yes, sir.
An equal to n raised to 1 by n.
Yeah,
limit 1.
it is given, right?
Yes, yes.
So that means limit of this one is 2, right?
Yes.
That means
Yes.
limit of is what? ln?
ln1. Sorry, 2.
ln2. Right? And in the above, what is the limit of the above one? This limit n tends to infinity, ln2 minus 1 by n. What is the limit of this one? But see, what is the limit of 1 by n? Hello?
0, sir.
0.
0. That means limit of the sequence is what? ln2, right?
ln2 by.
Yes, sir.
ln2 minus 0. So that is precisely ln2. So basically
ln2 by ln2 1. Okay.
This is 1.
Okay. Yes, got it, sir.
Sir, I also have doubt in fourth option.
Sir, just I have. Okay.
In same question.
Just a minute. What is the fourth question? Yeah, same thing. Okay. So limit n tends to infinity 4. Okay. So the question 4 into n power 3 by n, right? Minus 1.
Yes, sir.
Okay. So we know what? We know the limit n tends to infinity, n power 1 by n is 1, right? This is what we know, right?
Yes.
So this n power 3 by n is nothing but n power 1 by n power 3.
Okay.
Correct?
Yes.
Now can you do it?
Yes, sir.
Because see, if the limit n tends to infinity, an is a,
yes,
then limit n tends to infinity, an power q is aq, right?
Yes, sir.
So then the limit of this one is nothing but 1q, right? Which is nothing
Which
but
is 1.
1, right? So then what you have? You have basically
4 minus 3.
4 minus 1, which is 3. Correct?
Yes, sir.
Okay.
Understand.
Yes. Okay. Any other question?
Sir, activity 7.2, question 4 and 5.
7.2. 7.2.
Question number 4 and.
Yeah. So, okay. So what is the issue here? Question number 4 and 5. This is more or less, it's a formula, right?
Means just I am having doubt in option number 3, sin px equal to e sin x minus 4 sin cube x. So like I am unable to simplify to that form. And the same thing happens in the next question.
Okay, so something is given. So
yes, sine x plus y is given.
Sine x plus y. This is nothing but sine x cos y plus cos x sine y, right? Now, what you do, so you try to find the value of sine. So okay, so you want to find the value of sine 3x, right?
Yes, yes.
So sine 3x you can split it as sine x plus 2x.
X plus 2x. Okay.
Yeah. So what you will get? So eventually what you want to show sine 3x is nothing but 3 sine x minus 4 sine cube x, right?
4 sine cube x. Yes, yes.
Okay. So basically you need to get rid of this cos thing, right? Okay. So sine 3x is nothing but x plus 2x, right?
X
So
plus
now
2x, yes.
now what you do, you try to write this as sine
Sine x cos 2x plus cos x sine 2x, right? Yes. So cos x sine 2x, right?
sine
The
x
last
cos 2x. Yeah, correct.
Then cos x sine 2x.
Sine 2x.
Okay. Yeah.
Okay. So again you need to split this cos 2x and sine 2x, right?
Yes.
Yeah. So again I guess for
Okay, then we will have to substitute this cos 2x formula over here,
yes,
right?
yes,
And sine 2x over there.
yes.
Okay, got it. Then the next one also will be solved.
Yeah, so then you have to do it. I guess it's more or less so actually it's these two questions, question number 4 and 5, they're sort of interrelated. Okay,
Yes,
so-
yes. Now it will be
Yeah.
done. Yeah. Thank you, sir.
Thanks.
Sir, I have a doubt in question number 6 in this activity.
Same activity, right?
Yes.
Yes.
Sir, I didn't understand this. I got the answer wrong.
Okay, so
the fourth
so
option.
there are four options, right?
Yes.
So the first option says sine x is a unbounded function.
Yes.
Do you agree? Do you agree with
No.
So
No,
you are saying sine x is a unbounded function.
Yes.
So no, actually it's incorrect. Like if you draw the graph of the sine x, what is the graph of the sine x? It's a periodic function, right?
Yes, it's.
So if you see it's at 0, the value is 0. So it goes something like this, right?
Yes.
But if you see here, so this line, this is basically y equal to 1 line, right? Right? This line is y equal to -1 line, right?
Yes.
So that means the value of the sine is always in between 1 to -1, right?
Yes.
So that means f of x, which is sine x, it's always in between 1 to -1, right?
Yes.
That means it's a bounded function, right? The value, see, the value is basically in between some bounded region, right? That means this function is bounded, right?
Okay.
Do we have confusion with the definition of bounded function?
Yes, sir. Actually, I have confusion.
Then you should have asked the definition of bounded function, because see the definition says actually. So a function, let's say D, which is the domain from R. A function from D to R is bounded if the range of the function, okay, that means f of x, if f of x is basically in between two real numbers, if the value of the function lies in between two real numbers. Let's say this is n, this is same. If the value of the function is in between two real number, then you say that, which is, see, this is sort of equivalent to the fact that f of x is in between this interval, right, for all x in R in D, right? So if the value of the function is in between two real number, then you say that function is bounded. As you can see, in case of sin x, the value of the function is always in between -1 to 1, right? The value of the function is always in between -1 to 1. Okay, that's why this function is bounded. Okay, is it clear?
Yes, sir. So that creates first option correct. Sin x is bounded, and also third option correct, that 10x is unbounded.
Cos x is also cos x is bounded function, right?
Yes, cos x is bounded, but here it is given it is unbounded, so it is false.
So the first option is correct. Okay.
Yes, sir.
Second option is
wrong.
Incorrect. Tan x is unbounded function.
Yes, sir. Because its graph is like that. So, but in fourth option, how can we identify that?
Yes. This is your function, right? So the only thing is you have to make sure you have to find out the sort of range of this function, right? 2 plus cos x. So you know cos x is always in between 1 to -1, right? Correct?
Yes, sir.
Now you add 2 in both sides. Okay, in this, so what you will get? So 2 minus 1, which is less than 2, plus cos x, which is less than 2 plus 1. Correct?
3. Yes.
So this is 3.
Yes, that is 1.
1. Now if I take the reciprocal, okay, if I take the reciprocal, what I will get? I'll get 1 by 3 is less than 2 plus cos x, which is less
than
1. So now this, as you can see, this value of this function is basically in between two real numbers, right?
Yes.
That means it's a bounded function, right?
Okay.
Yeah. Is it clear? Yeah.
Yes, now it is clear.
Yes. Okay. Okay. Any other questions?
Yes, sir.
Yes, please.
So this is actually not reference to this week, but in week 6 graded assignment, the last question, the 12th one, even the answer key says that the answer should be the first option, and then the one that says that the function could be a graph of the log, and then the function range can be from -infinity to infinity.
So you are saying question number 12, graded assignment, question number 12, right?
Yes, sir.
Yes.
So yeah, so in that, but while marking, like when it says, right, the accepted answers, they're given a different set of answers and says that the answer is incorrect. But based on the solution that has been provided, my answer is supposed to be correct. So I'm getting confused.
No, sorry, like you are saying your answer is correct, but
the marking says it's wrong. Yeah, like the accepted answers have the different set of answers.
Yes, the same with me.
I still don't understand your problem. Like so you are saying, so you have bunch of options. So my first concern is whether question number 12 is same for all the students.
So it's a graph question for me.
Okay, so so the graph, this is a graph. So you have 4 options. Okay, let me share my screen. So this is the question, right?
Yes, sir.
Yes.
So as you can see, it's given that 3 options are correct, right? These three options are correct, right? Accepted
No,
answer.
sir, but in my answers, it is saying that different three answers are correct.
Yes, sir, for me too.
Then you need to check the options, like whether same.
Sir, may I interrupt? Hello.
Yes, please. Yeah.
Sir, in last session, Shrikant sir has clarified this set of options. There is some issue on the portal side. They will rectify it.
Okay.
You can refer to last session. I think he described it at last. I also have same query. I asked him and he clarified that it is the issue on IIT's end, so they will rectify it. Either they will give grace marks or it is equivalent to 0.
Yeah. So okay. So then yeah, I guess it's fine.
Because for some in my portal, the option the given graph is a graph of polynomial is showing correct, which is certainly not.
Okay.
So that
in my
yeah
too.
yeah. So Shrikant sir has already rectified this issue. You can refer to that video. Thank you.
Okay. Okay. Thanks. Yeah.
Thank you.
Okay.
Sir,
So then.
like, does mathematics also have a forum like stats in English does? I mean, this is the first live session I've attended because for the past few weeks I couldn't attend. So I'm just like wondering.
Forum. So you are talking about discourse, right?
Yes, sir, this course.
Yeah. Maths 1. All the courses have discourse. So you can go and ask your question in the discourse. All the courses, like whatever.
I don't think I've gotten access. Like I have access for stats 1 in English, but for maths I haven't gotten access.
Okay, in that case, you should write a mail to course support.
Okay.
So,
okay.
but certainly math 1 as a discourse. Okay, you can go and ask your question. Okay, the same, probably the same link, but you need some kind of approval from the course support side.
Okay, got it. Yeah.
Okay, thank you.
Thank you.
Okay, any other question, or shall I stop the session?
Sir, I have a question.
Yes.
Practice assignment question 7, question 3.
Practice assignment 7. Have you checked the solution? Hello?
No, sir.
Yeah, then you should.
Okay, sir.
Yeah.
So my approach was actually like en. I will take the value of n as 1. Put it here.
Okay, just a minute. Let me see the question. Okay, and then I'll see your approach. Question number, your practice assignment, question number 7, right?
Practice assignment 7, question 3.
Question 3. Okay, yeah. So tell me your approach.
Here en. I have taken the value of n as 1, substituted 1 in this equation. And,
so the first thing you should tell, what is the limit of a? So you have a sequence here, right?
Yes, sir.
So you have some sequence an which is 34n plus 7 by 50n plus 10, right? So my question is, what is the limit of this sequence?
Sir, I guess I have different numbers on my screen.
Okay, so tell me your whatever number you have. So what is your sequence an?
An is equals to 39n plus 34 by 39n plus 31.
39n plus 31. This is your sequence. Then it's more easy. So what is the limit of this sequence? You can write this as 39 plus 32 by n divided by 39 plus 31 by n, correct?
Yes, sir.
Now can you tell me what is the limit of this sequence? 1. So then you are done, right? If the limit of sequence an is 1, what will be the limit of this sequence an square?
Yes, it will be 1.
1 square, which is 1. Then basically you just need to substitute the things over there, right?
Okay, so actually it tends to sorry, that was not given, so I was not able to understand that n tends to infinity.
Yeah, so I guess in the solution actually we have solved it, so you can check the solution. Like so once you know the limit of an is not given. Okay, you need to find the limit of an. Once you know the limit of an, then actually finding the limit of the new sequence, what is given there, some bn, right? That is pretty easy. Okay, because now you know the limit of an. So basically it's the limit given. The new limit bn is nothing but it's some kind of linear combination of an, right?
That I can do, sir. Actually, I didn't know that n tends to infinity. That's why 32 by n equals to 0.
Oh, okay. Yeah. So that is basically the limit. Like that is how you find the limit of a sequence. So how you find the limit of a sequence? So you find the limit of the sequence by observing the behavior of the limit as n tends to infinity. So
okay. Now I got it.
Okay, fine. Okay, so now I'll stop the session now.
Sir, I have one more doubt. Can you
yes,
take
please. Yeah.
So 7.4, question number 11, part 2.
7.4, question number 11. Part 2.
Yes.
There is no part 2. Means option 2 you are saying.
Option 2, sorry.
Okay, yeah. Option 2, right? Yeah, so you need to know whether sequence is increasing or decreasing, right? So what is
sir, my question is, we have to only substitute values like 1, 2 and like check it or what?
Yeah, so the thing is, what is the sequence is what? Minus 6n? 6n minus 5, right?
6n minus 5.
So you say, so you want to check whether the sequence is increasing or not. Okay, so a sequence is increasing, right? If a n plus 1 is greater than an, right?
Yes.
That means an plus 1 minus an is greater than 0, right?
Okay.
So you know an, right?
Yes, sir.
What is an plus 1?
It's minus 1 upon 6n plus 1 minus 5.
So now you know an, now you know an, now you n plus 1, and now you check whether if you subtract an from an minus n plus 1, whether you are getting something positive or negative. If you are getting positive, then you can say that the sequence is increasing. Okay. Otherwise you can't.
Thank you, sir.
Thanks. Okay, so thanks. I'll stop the session. Okay, thank you all.
Good night, sir.
Good night.